Hi, Shreyas. How are you?
I'm fine, sir. How are you?
Great. So for today's lesson, we'll be looking at this type of questions that you're seeing on the screen. So remember, we've done this type of questions. Was it last week? I think it was sometime last week or early this week, where we were solving. I think on the previous lesson, we're actually simplifying this type of problems, isn't it?
Yes, sir.
So for today's lesson, I want us to have a look at how we apply those exponential rules um, to solve for the unknown. So obviously, you've got a list of those maths basic rules. I'm not sure if were you writing them down or you have them from your textbooks.
I wrote them down, sir.
Okay, 100%. So for each and every question that we'll be doing, we'll try to check which rule, what is it, which law is applicable. So I'm going to go through each of these questions from the start up until the end. For some of the problems, I might just go them halfway so that you continue to get to the final answer as part of you practicing this type of question. So the first question was 3 to the exponent x. This is equals to 81. So remember, Shreyas, I think as soon as we are completely done with this type of problems, that's when we'll move to the next lesson or next chapter. Because I think we've done enough of this type of questions. And again, even though we've been doing simplifications, but the approach is the same. So I just wanted us to solve this type of problems because they are actually in your standard, whereby even in the future you can still use these problems to practice. Remember, this lesson is recorded just in case in the future if you might need to refer to this lesson. So Shreyas, remember, when you're given this is an equation, obviously, isn't it?
Yes, sir.
So if you are given this and this is an equation, can you see you only have how many terms? 2 terms. So on the left, you've got 1 term. On the right, you've got 1 term, which means in this case, you just need to work out a number to its smallest base. And then from there, based on what is the base, it will guide you in terms of what's the next step. So what makes 81 Shreyas? How? Which other way can you write that 81 in an exponential form?
So we can say 81 divided by 3, which would be 9.
So let's see. 81 divided by 3, it's 9. No, it's 27.
It's 27, sir. Sorry, sir.
Yes, it's 27. So what so how can we write 81 in exponential form?
Also, we can say so I'm not really sure on this one, sir. Because
Okay,
I
so
know that 3 to the exponent 4 gives me 81.
yes, so that is how you write it in the exponential form. So you say 3 to the exponent 4. So that is exactly what I wanted, Shreyas. So you have to rearrange it such that the base is the lowest number. So can you see also, let's say, for example, okay, not necessarily an example, but that 3 is the lowest base for which we can say 3 to the exponent, whatever number, then it gives you 81. Can you see? So you
Yes.
couldn't say 9 to the exponent something in order to get 81 because 9 can be further simplified as 3 to the exponent 2. Can you see? So we just want the smallest base. And again, most importantly, the term on your left, it guides you in terms of what could possibly be the base on the right side. Because from this step, Trias, can you see the bases are the same, isn't it?
Yes, sir.
And for that fact, they fall away, then you equate the exponents, which means x is equals to 4. Then you are done, because this is an equation you need to solve for the value of x, and the value of x is equals to 4. Does it make sense?
Yes, sir.
Which means, how can we prove if that final answer is correct, Shreyas?
Yes. I just want to see, sir.
Okay. So can I guide you for this one?
Yes, sir.
So you prove it the same way at all times. When you say the unknown is equals to something as your final answer, it means when you say 3 to the exponent whatever x value and punch it on a calculator, it must give you 81. You remember this type of proving your final answer, Shreyas?
No, sir.
So I think for most of the questions that we'll be doing, I'll just show you how you use it. But it's the same as, remember that time when we said maybe 2x plus 1 is equals to 4, and then we had to solve for x. We said it's 2x, you transpose, then it's 4 minus 1.
Oh,
You've
yes,
got
sir.
2x. Yes, you still do the same. X is equals to, what is it? It's going to be 3 over 2. Then you must substitute your final answer wherever you see x from the original equation. So here, what are we going to do to prove if that answer is correct, Frias?
So we can transpose, sir.
Okay, so in this case, remember, we already calculated the value of x. So we substitute x there. So that means from that original equation, on this side, this is where you say 3 to the exponent whatever x value that you got, then it must give you 81. In that way, you know your answer is correct. So you are not solving here, but you're proving if your final answer is wrong or correct. So it's more like you're proving or verifying if your final answer is correct. So let's move to the next question. I think you will understand it better on the next question. So let's see. The next question is we've got 7 to the exponent x minus 3. This is equals to 49. So, Shreyas, how else can we write 49 with its lowest base?
So you can say 7 to the power of to the exponent 2.
So which means we've got 7 to the exponent x minus 3 is equals to 7 squared. So you're saying 7 squared now.
Yes, sir.
So do you want to guess the next step?
So since we have to say, since we got like to say the same bases, they fall away, and it will be x equals to 2.
Tell me what to write, Shreyas.
X equals to 2.
So can you explain that one?
So since we wrote our answer, we have to find out the whether 7 to the exponent 2 minus 3, which must give us 49.
Yes, but remember, Shreyas, remember, let me
Yes, sir.
maybe highlight that step over there. So remember, since the bases are the same, you equate the exponents. So what is the exponent of 7 on this side of the equal sign?
X plus 3.
What is it?
So it's x plus 3, sir.
Let me check something, Shreyas. Is it because maybe it's not clear? What is that sign over
I
there?
mean, it says minus, x
Okay,
minus 3.
so it's x minus 3. You equate it to Shreyas.
Yes, sir.
So you equate it to 2. So we say since the bases are the same, you equate the exponents.
Yes, sir.
So now that you have equated the exponents, do you want to guess what is the next step?
So I'm not sure what the next step is, sir.
Okay, so in this case, it's more like you can forget about all of this. Then we are back to those type of problems where we were solving for the unknown.
So to transpose, sir.
Yes. So uh, let me remove all of that. So you are right. We have to transpose. Then when you transpose, what happens is obviously x to the other side, it changes a sign, isn't it? Then it's going to be 2 plus 3, which is equals to 5, isn't it?
Yes, sir.
So let's see. So can you explain how do we prove if this final answer is correct?
So we have to take our final answer,
Mm-hmm.
and so we have to say that we have to put it where replace it with our x value, which
Mm-hmm.
should be 7
Mm-hmm.
to the power of 5 minus 3, which gives us
Mm-hmm.
49, sir.
Which gives us 49, which means this answer is correct, isn't it?
Yes, sir.
So remember, Shreyas, whenever you get a chance, make sure to go through our previous lessons so that you still remember how to solve this type of problems. Né?
Yes, sir.
So now let's move to number 3. So number 3, I'm also going to guide you in terms of how you solve that type of a problem. It's a bit different from what we've just done. So we've got 3 multiplied by 9 to the exponent x minus 1, which is equals to 27 to the exponent negative x. So remember, Shreyas, it's always the same approach. We want the bases to be in their smallest base. So obviously we know we've got that 3. What is 9? 9 is 3 squared. Do you agree?
Yes, sir.
So the exponent there is x minus 1. Then this is equals to, what is 27? I think 27, is it not 3 to the exponent 4? Let me see. 3 to the exponent
3 to
4.
the
No,
exponent
no.
3, sir.
Yes, 3 to the exponent 3 is 27. So the exponent there is negative x. Can you see? I did not change anything. I just what I did was just to rewrite those bases in that form, isn't it?
Yes, sir.
Okay, so now we multiply the exponents, which means we're going to have 3 multiplied by 3 to the exponent. Remember, it times that, and again it times that. So that means we've got 2x minus 2. I'm not sure if you understand that one, Shreyas.
Yes, I understand, sir.
Okay. Therefore, what else? On this side, we're going to have 3 that multiplies that, then it becomes minus 3x. Do you also agree with me on that one?
Yes, sir.
Okay, so let me see. Obviously, there's that invisible one, obviously, isn't it?
Yes, sir.
Which means the bases are the same. We can therefore add the exponents. So you remember that rule, which says when the bases are the same, you add the exponents. So we can apply that rule, which means we're going to have 3 as the base, then it's that one, then you add the exponents. So that exponent there is 2x minus 2, which is equals to this one. You just write it as it is. So I'm not sure if you understand up to this far, Frias.
Yes, sir.
So now you work out the exponent, which means you've got 3, you have 1 plus a minus 2, which is what? Which is minus 1. So it's 2x minus 1. I'm not sure if you understand that part, Frias.
Yes, I understand it, sir.
Yes. So at this stage, do you want to guess what could be the possible step?
So since our bases are the same, sir, we have to say that x. We have to say x. So we could say, sir, that x plus 2 minus 1 minus 3, sir.
Let me write it down. You're saying?
So I'm saying that x
Mm-hmm.
plus 2
Mm-hmm.
minus 1
Mm-hmm.
minus 3.
Mm-hmm.
And so we have to so we could then after that, so we could say x will equal to
Okay, so Shreyas, let me remind you something. Maybe you can write it down as part of your notes to say,
yes, sir.
as soon as you say, since the bases are the same, you equate the exponents. So when you equate the exponents, to equate, it means you must use an equal sign. Then, what is the exponents on this side, Shreyas?
The exponents are on the left hand side, sir.
Yes.
2x minus 1.
So it's 2x minus 1. On the right,
Negative 3x, sir.
negative 3x. So can you see, when you get to this stage, you just equate the exponents. So that means the exponents on this side and the exponent on that side, you just write it as it is. Nothing changes. Can you see?
Yes, sir.
So you can just make some notes to say when you get to this point where your bases are the same, you just equate the exponents. Therefore, after equating the exponents, the next step, you solve for the unknown. You can also write it as part of your notes. So when you solve for the unknown, it means you can transpose. You've got 2x, it changes the sign, it becomes plus 3x. You also transpose 1 to the other side, it becomes positive 1. Obviously, 2 plus 3, it's equals to 5x, which is equals to 1. Then you divide by 5. What you do on the left, you do on the right. You want 5 to cancel, and this is equals to x, which is equals to 1 over 5. So that part, Rias, did you understand that part, or would you like if I explain it again?
I understood that part, sir.
So it makes sense, ne?
Yes, sir.
Okay, so now let's move to a question number, what is it? It's question number 4. It's a bit different from question number 1, 2, 3. So can you see where's the difference? On question number 1, on the left, we have one term. On the right, we have one term. Question number 2, one term on the left, one term on the right. Question number 3, one term on the left, one term on the right. So question number 4, how many terms have we got on the left?
2.
2, sir.
2 terms, then 1 on the right. So number 5, 2 terms on the left, 1 on the right. 2 terms, 1 on the right. 2 terms, 1 on the right. So now, let's see. We've got 2 to the exponent x plus 1 is equals to 9. So according to our steps, firstly, we need to rewrite the number to their smallest bases. So 2, it's in its smallest base. So you can just write it as 2 to the exponent x. You can say plus 1, and this is equals to, obviously, this is 3 squared. But before that, I want you to notice something. So this is 3 squared. But remember, you can simplify this given equation because you've got a number and you've got a number. Why not transpose and work out 9 with that 1 over there? Which means you're going to have 2 to the exponent x, which is equals to 9 minus 1. 2 to the exponent x is equals to 8. So what is 8?
Sir, what if you divided the 8 by 2, which gives you 4, sir? Then the 4 minus 1, it gives you 3.
Wait. So you're saying, okay, so you're saying we've got 2 to the exponent x, then we have this 8, ne?
Yes, sir.
So you say dividing it by 2.
Yes, sir.
You cannot divide it by 2 because of that x as an exponent there.
Yes, sir.
So because you have the unknown as the exponent, then at all times you want a bigger number to be in its smallest form. You are going to divide by 2 if maybe you had 2 multiplied by 2 to the exponent x. That's when you can divide by 2 so that it cancels, and then you just remain with 2 to the exponent x. So this is a a very special type of a problem where the exponent is the unknown. So to remove or to solve the unknown, which is in the form of an exponent, you need to make sure that the bigger number is in its exponential form where the base is the smallest. Because in this case, this is the same as 8 to the exponent 1. But 8 can be further simplified such that it has its smallest base. I'm not sure if you understand, Shreyas.
I understand now, sir.
100%. So now, what is 8? How else can we write 8?
So for 2 to the exponent, so we can say 2 to the exponent. So we can say 4 to the exponent.
Okay, so another tip, guys,
2 to the
because
exponent.
on the left your base is 2, same time try to say 2 to the exponent 1, 2 to the exponent 2, 2 to the exponent 3. This is what gives you 8. So
Yes, sir.
when you're dealing with this type of problems, already because it's 2 which is attached to the unknown, which means on the right you are most likely to say 2 to the exponent something, which must take you back to that. It cannot be 7, it cannot be 3, because otherwise the bases won't be the same and therefore they won't be able to fall away. So
Yes, sir.
with this type of problems, the base which is attached to the unknown, it gives you a guide in terms of what could possibly be the base of the other side. So obviously there we've got 3, isn't it? So that
Yes,
means the bases are the same, they fall away, you equate the exponents. So now this is done because you say x is equals to 3, it ends there, which means if you substitute 3 there and say 2 to the exponent 3 and plus 1, it must give you 8. Obviously, 9. This is 8, then plus 1, it's 9, which means 3 is correct. So obviously, that one made sense, isn't it?
Yes, sir.
100%. So the other question is 2 to the exponent that plus 2 to the exponent x is equals to 24. So we've got 2 bases on the left. So remember, in this case, firstly, because of that sign which separates the 2 terms, it could be a sign of a plus or a minus. For that reason, separate the exponents. Separate the exponents. So after separating the exponents, write anything or everything as it is, which means now that you have separated the exponents, you can take out that as a common factor. So when you take it out as a common factor, in brackets, wherever there was 2 to the exponent x, then it becomes 1 multiplied by whatever which is 2 to the exponent 1 plus wherever it was that you write 1 is equals to 24. So then you can punch the whole of this on a calculator. Remember, I've got 2 to the exponent that. 1 times that is 2. 2 plus 1 is 3. Close. It's equals to 24. So can you see, Shreyas? You just
Yes, sir.
want to have a base to the exponent unknown on the left side. So you can divide by that same number, which is 3, so that it cancels. Remember, what you do on the left, you do on the right. So now that they cancelled out, you remain with 2 to the exponent x, which is equals to 24 divided by 3. Let's see, 24 divided by 3, this is 8. And you see, so that base, it serves as a guide to say possibly on the right side you can have 2 to the exponent something to give you 8. So what is that something? Obviously is 3, we know. Therefore, x is equals to 3. Remember, the bases are the same. They fall away. You equate the exponents. So, therefore, it means x is equals to 3. If you want to prove, you substitute it there and there. Obviously, this to the exponent 2 plus that, if it's 3, then it's 8. This is 8. 2 to the exponent wait, no, this is 3. 2 to the exponent 3, what is that? Let me
8,
see.
sir. Plus 1.
Oh,
Okay.
no, it's 4. It's 4 there, because it's 3 plus 4. Is this 3 plus 4? So it's
Yes,
2 to the exponent 3, which is 16. And 2 to the exponent 3, what is that? It's 8.
8.
So 16 plus 8 is equals to 24. So that means that final answer of 3 is correct. I'm not sure, did it make sense?
Yes, sir.
So let's now move to the other problem. Remember, this lesson has been recorded. You can always catch up at a later stage. So we've got that plus 1 plus 3 to the exponent x minus 1, which is equals to 90. So what is our first step? So as part of your notes, you can write it down. If we've got on the left, if we've got that sign that separates the terms, firstly, we need to separate the exponents, which means we're going to have that multiplied by that. Plus 3 to the exponent x multiplied by 3 to the exponent negative 1. This is equals to 90. So, what can we do? We can take out a 3 to the exponent x as a common factor. Take out a common factor. In place of that factor, you write 1 there. This is that 1 multiplied by 3 to the exponent 1 plus that 1 multiplied by 3 to the exponent negative 1. The whole of that is equals to 90. Therefore, you can punch the whole of this on a calculator. So you've got, let's see, it's the same as 3 plus 3 to the exponent negative 1. I'm getting 10 divided by 3, which is equals to 90. So, Shreyas, do you want to guess what can we do at this stage?
So we have to see which we have to cancel out.
So how can we work it out such that we cancel out, as you say, Shreyas? You don't have an idea, isn't it?
Yes, sir.
Let me see. It seems like we've got 2 more learners who joined. Let me see. Levo, do you want to guess what could be the possible step here? Lerato, do you want to guess it?
So I think we should divide by 10 over 3 on both sides. Because
Okay,
we've got
so Shreyas, let me guide you on how to do it, as Lerato said. What do you want to cancel, Shreyas?
No, sir. You can carry on, sir. I was making a mistake, sir.
Okay, so remember, you've got 3 to the exponent x, and then you've got that as your coefficient. So you want to remove the whole of that. You were on the right track. You wanted to cancel something, but don't worry that much whether it's in exponential form or any other form. So you can divide by exactly the same thing as it is, because this is exactly what you want to cancel. Therefore, you also divide by the same thing on the other side. So that will cancel, that will cancel. You remain with 3 to the exponent x, which is equals to, what is that one?
It's 27, sir.
Are we
27,
all
sir.
getting 27?
Yes, sir.
Okay, so here, obviously, this serves as a guide that possibly on the right we can have 3 to the exponent something. So what is that
3 to the
something?
exponent 3, sir.
3 to the exponent 3 is 27, which means the bases are the same. We equate the exponents. So 3 is equals to x, or x is equals to 3. Therefore, it's done. So you can substitute 3 there and punch all of this on a calculator and expect to find 90. So I'm not sure if that calculation makes sense for everyone, or otherwise, if you want a repeat of explanation, you can just let me know.
No, sir.
It made sense, ne?
Yes, sir.
Okay, so now let's move to the last problem. Or otherwise, I'm giving you this last problem as your homework. It's almost the same as that one. So before I end this lesson, you can just write it down and work it out as your homework. So let me know once you're done copying it, so that
Yes, sir.
I can. So you're done copying it, isn't it?
Yes, sir.
Okay, 100%. So, guys, this brings us to the end of our lesson for today, especially for mathematics. So shortly after this lesson, will be starting with what is it? Momentum. So I've already drawn a sketch of what we'll be doing as soon as we are done with this lesson. So guys, thanks very much for joining. I'm now going to stop the recording. So 38, okay, stop recording.